In the previous video, we discussed about the phenylketonuria. If you want to watch that video first, the link is in the description. Now here we are going to discuss about the alkaptonuria, which is also an inborn error in protein metabolism caused by mutation in HGD gene located at 3q21 to 23. This HGD gene drives the synthesis of enzyme homogentisate 1,2-dioxygenase enzyme, which is crucial for protein metabolism. We see this enzyme acts on HGA, that's homogentisic acid, and converts it into MAA, that's mallyl astoacetic acid. But when we have the mutation in HGD gene, that time we are not making this enzyme, and homogentisic acid is not getting converted into mallyl astoacetic acid. That ultimately leads to accumulation of HGA within the body, which proves to be fatal in many ways, which we are going to see later on in this video. We also see this condition shows autosomal recessive pattern. Now let's see the alkaptonuria metabolic pathway. It starts with phenylalanine amino acid, which is acted upon by phenylalanine hydroxylase enzyme and gets converted to tyrosine. If this enzyme, that's phenylalanine hydroxylase, is missing, that condition leads to PKU, that's phenylketonuria, which we have already discussed. Then this tyrosine is acted upon by tyrosine aminotransferase enzyme, and we get the 4-hydroxyphenylpyruvic acid. And if this aminotransferase enzyme is missing, that condition is termed as tyrosinemia type 2. In the next step, 4-hydroxyphenylpyruvic acid is acted upon by 4-hydroxyphenylpyruvic acid dioxygenase enzyme and converts it into homogentisic acid. If this 4-hydroxyphenylpyruvic acid dioxygenase enzyme is missing, that leads to tyrosinemia type 3. Now we see this homogentisic acid is acted upon by homogentisate 1,2-dioxygenase enzyme and converts it into 4-mallyl astoacetic acid. And if this HGD enzyme is missing, that condition is termed as alkaptonuria. Now let's keep this condition as such. Further, let's say all the enzymes are working properly. So from here, that's 4-mallyl astoacetic acid is converted to 4-fumaryl astoacetic acid by the action of isomerase enzyme. And then this is further converted to fumaric acid and astoacetic acid by the action of hydrolase enzyme. And we also see the branching of this pathway, that's 4-mallyl astoacetic acid plus 4-fumaryl astoacetic acid gives us succinyl astoacetic acid. And later this is converted to succinyl acetone. So this is the whole metabolism of phenylalanine amino acid. And within these reactions, we are going to see how the alkaptonuria occurs. The blockage is here. The HGD gene is missing and we do not get the further reactions. So the pathway ceases from here. But when we get the accumulation of homogentisic acid, it is acted upon by HGA polyphenol oxidase enzyme. And this is kind of an auto-oxidation reaction. And this homogentisic acid is converted into benzoquinone acetate. Now from here, the polymerization starts. We see the benzoquinone acetate is polymerized into alkapton, which is an ochronotic pigment. We see this alkapton is dark pigment from which the alkaptonuria gets its name. The alkapton is deposited into ear cartilage, ocular tissues and in collagen. The deposition of this alkapton in the various tissues is termed as ochronosis. And then we move on to the symptoms. First of all, the urine becomes black when exposed to air, shown in the diagram. And we see the ochronosis of certain tissues, like black spots in the sclera of eye, shown in the diagram. We see the discolored ear and dark earwax, and blue-black specular discoloration of skin. Then there is osteoarthritis of spine, hips, shoulders and knees. And finally, we see the kidney, prostate and bladder stones due to HGA accumulation. Now let's see its diagnosis. The first important traditional test is that we keep the urine standing, and if the urine turns black or dark, it's positive for alkaptonuria. Second is the ferric chloride test. If the perchloride is added to the urine, it will turn the urine black in the people with this condition. Third one is skin test. We see a skin biopsy can be used to diagnose alkaptonuria by revealing yellowish-brown pigmented bodies in the dermis. We see in this picture the banana-shaped yellow-brown deposits in the dermis are a classical histological finding in the skin of alkaptonuria, also known as endogenous ochronosis. Fourth one is gas chromatography mass spectrometry, that is GCMS analysis. Is the gold standard test for alkaptonuria by detecting the amount of homogentisic acid in 24-hour urine sample. And last one is the DNA testing to check for mutated HGD gene. So this is what alkaptonuria is and its metabolism. I hope you like the video. If you like it, give it a thumbs up. Do consider supporting my work on Patreon or YouTube and make sure to subscribe to this channel. Thanks.